Welcome to qnawire.
So in this question, we are asked to find the width of the barrier for this proton that starts out with initial kinetic energy of 50 electron volts. And this proton encounters a barrier with a height of 70 electron volts. We're given that the probability of the proton tunneling is 3 times 10 to the negative 3. And we are asked to find L, which is the width of this barrier. So we can recall our equation for the probability of tunneling T, and this equals G e to the negative 2kL. And we can also recall that the equation for G is equal to 16 E over U naught times 1 minus E over U naught. And our equation for K is the square root of 2m U naught minus E all over H bar. So now we can go ahead and manipulate our equation, the T equals GE to the negative 2kL. We want to solve for L. So in order to do that, we can divide, so let me quick show, this is the equation that we're going to talk about right now. We're going to divide the left and right by G. So we can get T over G equals E to the negative 2kL. Now, in order to get rid of this negative exponent, we can flip around G and T. So now we can have G over T equals E to the positive 2kL. So now, to solve for L, we can take the natural log of both sides. And we get natural log of G over T equals 2kL. And we can divide by 2k. So our width of our barrier is going to be equal to 1 over 2k times the natural log of G over T. So now we want to find out what's K and what's G. So K, like I wrote above, equals 2m U naught minus E over H bar. So our M is our mass of our proton, our U naught is the height, which is 70 eV, and our E is our initial kinetic energy, which is 50 eV, and H bar is just your constant. So we can plug in all of our values, and we find that K is going to be equal to 9.8 times 10 to the 11. And then next we want to find G. So our G equation, like I wrote above, is 16E over U naught, 1 minus E over U naught. So E, again, 50 eV, U, again, 70 eV. We plug those in. We find that our G is equal to 3.27. So now that we know K and G, and we already were given T above, which was 3 times 10 to the negative 3, we can now plug all of these values into our equation for L. When we do that, we get 1 over 2 times 9.8 times 10 to the 11 times natural log of 3.27 divided by T, which is 3 times 10 to the negative 3. And you should get an answer of 3.6 times 10 to the negative 12 meters, which can also be written as 3.6 picometers. So that is the length, or that is the width of our barrier that our proton just encountered. And so now we're asked to compare how would this be different for a proton or for an electron. So what we just solved for was for a proton. But for an electron, we would have a smaller mass. So mass would be smaller, and therefore our K value is going to be larger. And if our K value is larger, then our L is going to increase. Oh, I am sorry. I meant to say that our K value is actually going to decrease. So for an electron, the mass will decrease and the K value will decrease. And so what that means is that the L is going to increase because in your L equation, you have 1 over 2K. So if your K value decreases, then you're dividing by a smaller number. And so your L value is going to increase. So L value is larger for an electron than it is for a proton.